Hello everyone, this is Suresh here. Welcome back to another lab session in Google Cloud. In this lab, we will see classifying images with linear model. So without any delay, let me start the lab. And in this lab, we are not going to discuss anything theoretical or any technical terms. We are only going to execute the tasks that is provided. Let me open the new incognito window. So let me do the setup first. Okay. So at any point, you can pause the video and go through the overview. So in this, we are going to launch the Vertex AI notebook, clone the repository, and classify the image with linear model. So let's get into the, so setup is already done. So let me enable the APIs as well. So for that, navigation menu, Vertex AI dashboard, enable all recommended APIs. So let me check the progress. Okay. Now let's launch the Vertex AI Workbench. So you can see in the Vertex AI, you can click out the Vertex Workbench and user managed notebooks. So I think in the notebooks are already enabled. So let me create new. So let me give the name as lab workbench and zone in the US Western zone. So click. So now I think the step 2 and step 5 is done. Step 4, step 3. So the small change in the navigation. So in step 3, we will select 2.11, but in the lab it is given as 2.6, but that is fine. Rest all, I will leave it to the default settings. We'll continue with the disk, continue with the networking, IAM and security, continue system health. So click on create. This will take about 2 to 3 minutes to create and provision the open for Jupyter. So open Jupyter Lab will take some time. So it will take another 2 minutes. So let's wait for it. I'll pause the video. Okay. So we have the open Jupyter Lab. So it took about 2 to 3 minutes. Let me open. And in the meantime, I'll check the progress. So next, once the Jupyter Lab is open, we will open the terminal and clone the repository. This will take another few seconds. So click on terminal, clone the repository. You can see a folder and all the files will get downloaded in this Jupyter Lab. So let's wait for this to download completely. Now you can see all the files is 100% completed downloaded. So let me check the progress. In task 3, we'll navigate to training data analyst, courses, machine learning, deep dive to computer vision 1, and in the labs, classify images with linear model. Classify images with linear model. This is the file. Okay. So for the benefit of the doubt, benefit of the time, right? Here actually in few steps, right? Let me show you that. We first edit here all outputs. For example, if you see here in few of the steps, there are to do options. So we need to write a code in that place. See one place and here to do two. Okay. So for the interest of the time, what I will do is like I will directly go to the solutions and from there I will execute. For that you need to navigate. So you can see the solutions. Okay, the same folder, just one step back, and you can see a solution. In that solutions, you can click the linear one. Here, this file will have the solutions. So let me check the progress, but we still have a lot of work to do here. Mhm. Okay, let's do this. Let me, okay, first we'll start executing the cells. So this is to import the TensorFlow, Shift Enter, or you can use the run button. 2.11 is there. So next, install the PyDot and other things required for us. Now images to be used in this one is already prepared and stored in the public kit in Google Cloud. So if you want to see that as well, you can just select it. So this is going to open our public repository. Here you can see from this position only, from this location, we are getting this uh, data. So let me execute this as well. Now you can see here, you can pause the video as usual. You can pause the video and go through this text. But whatever they are saying is here we have two sets of data. One is training set and another one is evaluation set. Training set will have about 90% of images and 10% of evaluation set. So here, yeah, from here we'll start working on it. So to execute, here we have a resize the image to decide. So again, I'm not going to dip the details about these files. I mean this code. So I'm going to the solutions and from there I'm just copying the required code for me and then pasting it over here. Okay, let me put shift enter. So this is for the reading and decoding the image data. Let's do that. There are available classes daisy, dandelion, roses, sunflower, and tulips. Now let's get into the next image, show image. So this is one of the flower is getting displayed for us. File name on the flower here. Let's have a few tulips. I think it will show about 5 tulips here. Okay, exactly, because you can read the code. I suggest you go to the line by line code and then get this displayed. Understand the code, that is the key here. understanding the code, what this NumPy does, what is the IM show, and how this Python code works, everything you need to do your own research. As I mentioned earlier, this is only to execute the task provided here. So now let's see the subplots. Okay, we have a different set of data. Again, this is again a concept, so you can go through the content, understand this. So now here, passing the CSV line, CSV row. So let's see. So here we are passing the training set and evaluation set. Implement the linear model. So again, I'm going back to the solution. This is Keras sequential model. They are planning it. Yeah. If you see, this is a Keras sequential. In the sequential, the flatten is image height, width, and number of channels, and the class names with the activation function called softmax. And the optimizer is Adam optimizers and sparse category cross entropy. These are all the things, and metrics we are calculating is accuracy. These are all major in-depth or most fundamental things which you have to learn on your own. So let me execute the step and let's plot model in Keras model. So this is the plot. So input layer is having 224. So this is the shape. The output is also the shape. And this 150, 528, just multiply it, flatten it. So multiply 224 times 224 times 3. So you will get the output number. So the input layer is this, and the flatten layer will have this number, and the dense layer will have 5 nodes. Okay. So let's see the summary. You will have more detail here. Okay. Now you can see now the dense layer is having 5, and the number of parameters is 752k total parameters, and yeah, all the parameters are trainable. So you just go through the content here, but let me fit the model on the evaluation set. So there will be a 10 epochs. So the first epoch getting started, it will take some time. Let's wait. You can at this is the time you can use your time to go through the content provider. I'm surprised to see slash unknown, because at least we should have known what is the time. And also this is the 10 epochs, right? So I think we are using the entire data set here. Training data set, validation data will be evaluation data set. I'll pause the video because I'm not sure how long will it take. So once this all the epoch system, then I will just scroll through and show you what was the output. So now you can see there are about 330, right? And this is getting trained, and you can see the variation over here. You can see the loss is coming down from 16 to 12. The 10th epoch is still getting trained, and the loss is coming down, and accuracy is going up, and value loss is going up, and value accuracy is on same stage if I see the numbers. So let's wait. Okay, it's on the same stage. So now let's move on. You training plot, loss and accuracy history. So let's plot this, and you can see the loss and value accuracy, epochs. And at any point, you can pause the video and go through you can analyze that. So that will take additional time. So I'm skipping those steps and then continue with the next steps. So here we are seeing the logit and sigmoid functions and how the training was completed. So now importing TensorFlow slots ABCDE category. You can see probability softmax on every category here. Now let's get the predictions, plotting the predictions. Here the batch prediction is, let me go to the solution here real quick. Predictor, batch image. So that is executed. Now let's get into the predictions for the training set, because this is the files we had it in the initial set. You can see that in the initial they have given the training set as a links. Here we go. So going back here, now you can see the predictions for the training set uh, with all the flowers. I don't know how this image came here. That's fine. Similarly, with respect to the evaluation predictions. Now the class names, layer 1, and all other information. So let's see this. So Daisy, Dandelion, Roses. So these are all the weights for Daisy from and to, and for tulips. Okay. So this concludes the session. So let's see now if I'm able to complete this lab. Perfect. So thanks for joining. So this concludes our lab. So have a great day.